Hi everyone, welcome to Math 101 Pre-Algebra. This is a picture of the book that we're using. If you don't already have it, you can get it on the XYZ Textbooks website. Information about that's in our online Canvas course. Most of the information for this course is in Canvas. That's where you'll get access to the syllabus and all the course modules and all the homework assignments and tests, and it's an easy way to keep all our communication about the course in one inbox. And so a couple of points here. Office hours are by appointment this semester, so if you want to meet, just contact me and we can make an appointment, no problem. You can email me if you can't get a hold of me through the Canvas inbox, or you can give me a call, and if I don't pick up, leave a voicemail and I'll definitely get back to you. I'm going to schedule weekly meetings on Teams. I've already done that. You may have already noticed you've been invited, so check your email if you haven't, and it's an opportunity for us to connect live and answer any questions you might have. The Tutoring Center is open this semester for in-person tutoring from 10 a.m. to 2 p.m., so I encourage you to take advantage of that. There's going to be a tutor available for your course that whole time, to my knowledge, so stop in. That's appointment tutoring, so you will have to kind of schedule it a little bit, but it is available to you, and it's really high quality in-person tutoring. Can't encourage it enough. If you can't do in-person tutoring, another good option is Brain Fuse, and there's a link to it right in our Canvas course, so you can get, if you're stuck on a problem, you can get to connect with a tutor right through the Canvas course and get your question answered rather than having to wait. And then the third option, of course, is to meet with me, and I'm happy to answer any questions you have, so please reach out. The textbook also has videos that are pretty good examples, and to access them for the relevant sections, you just scan the QR code inside the textbook. Whether you have a physical copy or a digital copy, it should work. So here's an example of that QR code. So be sure to check those out. They're pretty cool. There's different instructors showing you examples using slightly different language, and there's some Spanish examples. So definitely check those out if you're interested. So this whole chapter is about whole numbers, right? So the whole numbers are, in a sense, all the positive numbers and zero. And so those are the ones we're going to be focused on in this chapter. We will move on and we will talk about, other ways to label numbers. But for this chapter, we're going to focus on whole numbers, really ground our understanding in whole numbers, and then we can apply that to other kinds of numbers. So this first section, 1.1, is all about place value. So that's what we're going to focus on: place value, place names, and we'll go from there. So some of the objectives here in this 1.1, we're going to identify place value for digits. In other words, just identifying what place values a digit is in. And then we're going to write those numbers in expanded form, which just means to write a number in such a way that you clearly identify all the various place values. And then we're also going to write those numbers in words. And believe it or not, this is actually kind of the trickiest part. And so we'll definitely spend some time practicing that. Here are some key words that might come up, and we'll go over them as they come up in context. So this first table, table 1, shows you kind of the basic first 7 place values, starting, interestingly enough, even though we read from left to right, and when we read a number, we start with its biggest place value in the naming, we actually start thinking about the number from the right. And so we start thinking about it from the ones column, because if we only had 1, well, that's where it would go, whereas if we had 1,000,000, of course, then it would go out in the millions place. And so really we're starting with 1 and we're building to the left as numbers get bigger, which is kind of an interesting quirk. One thing we do is after 3 place values, we use a comma to denote a change in place value. And it helps us to do 2 things. One is it helps us to read a number and stay organized more quickly because it's easier to count in 3s, because for some reason that seems to be a kind of a natural grouping that's easy for us to handle visually as well as orally and auditorily. But also it helps us to know the names of the various place values. So after the first place value is ones column. Then if you have 10 ones, well, then you have a 10. So you're in the tens column. Then if you have 10 tens, you're in the hundreds column. After the hundreds, then we get a new unit. We get the thousands unit, and we get a comma. And so 1 followed by a comma and 3 zeros is in the thousands unit. And then the next 2 place values are just extensions of the thousands. So instead of just thousands, in the next place value we have 10 thousands, and then we have 100 thousands, sort of like we had ones, tens, hundreds. So the thousands is sort of like the 1,000s. And so that helps us to see, oh, and then this pattern repeats. We get 3 more place values, and then we get another comma. We get the second comma, showing us the next place value as well as showing us another group of 3, and we get the millions. What do you think comes after millions as we get larger? Sure enough, 10 millions and 100 millions. And then we get a comma, a new place value, and the pattern repeats with tens and hundreds of that place value. So whether we're talking about billions, trillions, or quadrillions, or even more, we can simply follow the pattern of saying, oh, that's a billion, or that's 10 billion, or that's 100 billion by the place value. So that's one thing that's really useful about our number system. Now, this number below has each place value labeled. And you can see how there's no ones, but we still need a 0 there as a placeholder to show how far this number really extends, right? If we didn't have that, then the number would be a digit shorter. It wouldn't be in the 10 billions, it would be in the billions, and then the commas would be in the wrong place. So we use zeros as placeholders if we don't have a unit, like in the case of the ones and the millions units here. Every other place has a non-zero digit in it, so it has, some amount of 10 millions, in this case 9 10 millions, or 90 million, right? And that's not all of it, right? To know the full number, we really have to start, even though we start numbering kind of from the ones in terms of thinking about building up, we label the number by starting on the left. So we look for the biggest place value, right, which is always the one on the left because it's always in order. In this case, that's 10 billions. And so this is 73 billion 890 million 672,540. And that's how we read it. And so what's really nice about the place value system is by having names for these place values every third, or rather every fourth place value, right? Or after every 3 having a new place value unit, that helps us to stay organized. It helps us to read the number in its units. So let's have a look at some more examples. Let's write a number in expanded form. Well, how do we do that? Well, essentially all we have to do is write it using its place values. So in this case, the number is 5,478. So instead of 5,478 in its condensed form, we're going to expand it and write each unit with the corresponding number of zeros and any necessary commas to show its place value. So in this case, the 5,000 gets its own term, the 400 gets its own term, the 70 gets its own term, and the 8 gets its own term. Now, if we add all these up, of course, 5,000 478, I add all these up, of course I get 5,478. And so expanding a number is just a way of showing its place value really clearly, and this can be helpful for a couple of things. One really good example is money, because money comes in different denominations, which are essentially like place values of money. And so to make it really simple, we're going to leave out the 5s and the 20s and the 50s, and we're going to focus on the multiples of tens, and we're going to include the ones to make this kind of straightforward and simple so we can get a sense of how place value connects. So there's a $1 bill, there's a $10 bill, there's a $100 bill, and there are some rare $1,000 bills that you could probably get if you special order them through a bank. So if we've got these denominations, or say we're a bank and we're making a large cash transfer, and I need these big denominations, this would be really helpful. Rather than having to have, say, you could imagine, instead of $5,000 bills, I'd have to have 54 $100 bills. Well, that's a lot of paper. That's a lot of weight even, and that's probably not very easy to carry. It's not very realistic. So by having a larger denomination, I can have a fewer number of those, right? In this case, it's nice because it corresponds to our place value system. So if I have $5,000 bills, 4 $100 bills, 7 $10 bills, and 8 $1 bills, that's the same as having 5,478 $1 bills, but way more convenient. And that's a way to kind of think about expanded form as being really relevant to life. So if we want to write a bigger number in expanded form, like take a look at example 4 here, write 56,094 in expanded form. So what we need to do is write each digit, the 5, the 6, the 0, the 9, and the 4, and we'll talk about the 0, with its own kind of place value, right? And so in this case, the 50,000, right, the 5 in the 10,000s unit gets a 5 10,000s, which is 50,000, right? That's what 5 tens is, 50. The 6,000 gets its own. Then the 0, we don't really need to say we have 0 hundreds, right? I wouldn't tell you, for example, that I have, if I was telling you how much money I had, I wouldn't tell you that I have 0 $100 bills. That wouldn't make a ton of sense, because we just don't do that. I don't tell you, oh, I have no Ferraris. Well, you kind of assume that, right? And I don't need to say that. So that's why we don't include that. Because also, if we were to add it up and we didn't have something in that place value, we would simply have zeros to collect, and then that would be our placeholder. Then we have 90, and we have 4 on its own. So we can write it in expanded form, and we don't have to include the 0 hundreds. If you include the 0 hundreds, it would look kind of awkward. What would you do? Would you have 3 zeros next to each other? That's kind of the same as 0. So it doesn't really add anything, and so we can exclude it when we write in expanded form. Okay, let's take a look at table 3. They've got some numbers written out in their numeral versions, like say 25 and 47, 93, 88. That's that first row. And then just to the right, in the English, their written version. So 25 corresponds to, of course, 25. Notice how it's written, with the place values in order, just like you would expect, just the way it's written, just the way it sounds. And with these 2-digit numbers, we need to hyphenate any numbers that don't end in a 0. In other words, that have kind of an even number of tens. And so in the case of 20, that's its own number. 30, 50, those are the examples we have here. 60, 70, 80, all of those, they are one-word numbers. But the moment you have something like 31 or 93, those are 2-word numbers that need to be hyphenated. You don't have to hyphenate the hundreds, you don't have to hyphenate the thousands, but if you had something like 47,000, you would have to hyphenate the 47, right? So you would say the only thing you'd have to do to change this number to this number is say 47,000. But you would still have to hyphenate the 47 as a 2-digit number. So that's something to be on the lookout for. And it would be the same if I had 147,000. I would simply have to write 147,000. And so hopefully you can get a sense of when you need to hyphenate and when you don't. We're looking at when there's digits in both the tens and the ones unit. Then we're looking at hyphenating. With the exception, of course, being the numbers like the teens. So the teens are their own numbers, like 16 and 15, right? So here's 15. So we don't have to worry about hyphenating that, because instead of saying 5, 10, we've said it for so long, we say 15, we've created a 1-word number, even though it's a 2 place value number. All right, a tens and ones. Okay, so armed with that knowledge, let's take a look at example 7. Write each number in words. Let's look at example A, 452. Notice how we'll start with the biggest place value, which in this case is the hundreds. So we'll specify we have 400, right? Notice that's not hyphenated because that's in the hundreds place and we're just saying how many hundreds. But then the 52 is hyphenated because it's got a tens and a ones. Let's have a look at B, 397. So we have 300, and then we have 97. And since 97 is a tens and a ones digit, then we have to specify that it's hyphenated. But notice the 300 was not, just like 3,000 would not be. Now let's look at the last example, C, 608. Notice what I said and notice how it's written. A lot of folks say 608, but the "and" in numbers actually corresponds to the decimal point, or signifying that we're going from a whole unit, the ones, into the fractions unit, right? Somewhere on the right of the ones. And we'll talk about that later. But for now, it's important to note that the "and" doesn't really have a place on the left of the decimal point in numbers. And so all these numbers are whole numbers. That's the only kind of numbers we're going to talk about right now. So 608 looks like 608. 608 would look like 608, maybe, and 8 tenths, or and 8. We don't really know what the unit is. That's the trouble, actually. We haven't specified the unit. And so because it's a whole unit, this one is not what we want. 608, notice, no "and", just 608. Also no hyphens, because there's a 0 in the tens unit, so it's not a double-digit answer there. Okay, let's have a look at some more examples here that are slightly bigger. And in fact, let's just go straight for the big one. Let's have a look at this note here. Notice how the comma separates the thousands from the hundreds. We will always use a comma here. Later, we will also use a comma after millions, billions, trillions, etc. So in other words, the first 3, the ones of a place value, the tens, and the hundreds, they're going to be a group of 3, and then after that we go to a new place value. So instead of ones, we have 1,000, right? And then the process repeats, and to show that we need a comma. So just like we use a comma writing the number in digits and numerals, we have to use a comma when we write a number in words. So if we look at example C here, or sorry, problem C, part C of example 8 here. It's 547. I read to the comma, and now what's that place? Well, it's the first comma, so that means it's the thousands place. So it's 547,801. So I don't have to write the tens place here, right? And I definitely don't want to write an and. So I see here for C, 547,547. 47 is a 2-digit number with a tens and a ones unit, so it's got to be hyphenated. And it's 1,000. It's not just a ones, though. It's a 1,000 unit, so it's a 7,000 here, 47,000, comma, to show that I'm moving from the thousands into the hundreds, tens, and ones, kind of the ones units, 801. And so it'll take a little getting used to, especially if you're not used to writing your numbers in words, or not used to paying really close attention to things like the and or where the comma goes. But just practice it a little bit and you'll get the hang of it. Let's review some of the key concepts from this section before we go on. So give, and these are all, this is an opportunity for you to respond in your own words. So if you'd like to pause the video and try to answer these questions before we go over them together, that would be great. Now we'll go over them together and we'll talk about kind of how they relate to the key concepts here. So A, give the place value of the 9 in the number 305. I'm sort of giving away what I'm doing here. I'm reading the number with all of its place values. I'm not just reading 305, 964. That wouldn't really help me at all. Instead, if I read the number properly with its place values, then the place value of the 9 becomes very clear. 305,964. So for A here, 305,964. I want to know this 9, what place value is it in? Okay, well, I start on the right, I get the ones, the tens, the hundreds. So this is the 900, or this is the hundreds unit, and 900 is the way to think about what that 9 represents. It's not just a 9, it's a 900. All right, let's take a look at B. Write the number, and again, reading it with its place values out loud, I'm doing this as much for my benefit as for yours, will help me to write it properly. So for part B here, write the number 742 in expanded form. So 700 plus 40 plus 2 would be 742. So each digit got its own place value with the corresponding zeros to show what place value it's really in. And if I add these all up, of course, I could check my answer and I would get 742. That's how I know my expanded form is correct, and correct for the condensed version. Okay, let's take a look at C. Place a comma and a hyphen in the appropriate place so that the number 2,345 is written correctly in words below. 2,345. So we have to put a comma and a hyphen in. Well, the comma is kind of the easy part because it goes after the place value. So what place value is the 2 in? It's in the thousands, so it represents 2,000. So after 2,000, we get a comma. So 2,000. 300, does that need a hyphen? No, the hundreds place doesn't need a hyphen. We just list the number and the fact that it's 100, and we can go on to the tens and the ones, which is where, in fact, we need to be on the lookout. Because if the tens and the ones is the double-digit number with a non-zero, right? Then we will need a hyphen. And so in this case, the number is 45. So 2,345 should look like that, more or less. Okay, so that's part C. We did it up here. Now part D, this is interesting. And it sort of gets to the most interesting parts of math that it seems like we often don't have time for, right? We're so busy calculating and figuring and working with maybe kind of real examples. And so let's think about this question that's kind of interesting. D, is there a largest whole number? Well, if I think about the number line, and I'm going to start at 0, right? I'm going to say I have nothing, and then I'm going to move to the right as I have whole amounts of things. So if I have one thing, there's one thing, two things, three things, four things, and I think you're starting to get the idea here that I can keep counting for a long time. And then what happens when I run out of digits? I've used 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. I could come up with some kind of a new symbol to represent the next amount of things, but instead we decided to use what's called a base 10 number system, where after the first 10 digits are used, I can repeat with a 0 placeholder showing that in fact I have 1 10 and no ones. And so the number 10, like all numbers after 10, whole numbers at least, is composed of the digits 0 through 9, the first 10 digits of our number system. It's really easy to start counting with 1 and forget about 0, but 0 is kind of like the first number in our number system when we think about whole numbers. Now, as we keep going, we get 11, we get 12, we get 13, and we're off the page here. But do we ever run out of place values? Now, you might not know the names of all the place values after, say, the trillions or the quadrillions or the quintillions. Kind of guessing here what's out there, because those numbers are so big that we hardly ever encounter them, right? And so while we could go on writing numbers forever, at some point a number might be so big it would take more than a human lifetime to write out, in which case, while there are bigger numbers, there are certainly numbers that we're more interested in using sometimes. And so we have this concept, right, that there is no largest whole number, and we can just create larger whole numbers as we need them, right? And in our minds, we can go out to a place we call infinity, which is an idea, not really a number, that says that as far as you want to go on this number line, using the place value system that we've come up with, you can keep building bigger and bigger numbers, and there doesn't seem to be any limit to how big those numbers can be. Even if we don't necessarily encounter them in our day-to-day lives or even in our astronomical and scientific pursuits, we know that it's out there and we can use it as a tool. And that's really the point about math, is that we represent numbers in an infinite number of ways in order to solve problems, make sense of the world, and sometimes even have fun. So I'll leave you with that, and we'll meet again in 1.2.